Okay, we were looking at successive differentiation. We had looked at explicit functions, implicit functions. Now let's look at parametric functions. Remember, what are parametric functions? X is equal to f of t and y is equal to g of t. So dy by dx would be dy by dt divided by dx by dt. So that we will end up with dy by dx after cancellations. Okay, let's look at examples now. Let's say x is equal to a theta minus sine theta and y is equal to a 1 plus cos theta. So here dx by d theta. So we have to differentiate with respect to theta. So this would be what? A as it is 1 minus sine theta is cos theta. Y is equal to a as it is 1 is 0. Cos theta is minus sine theta. This is equal to minus a sine theta. Now we can stop at this stage, but you need to be very comfortable with the identities of trigonometric identities to be able to figure out the further simplification. Is there some way by which we can make this similar to this? A remains as it is, but this 1 minus cos theta and sine theta. Now one way in which we can write this is minus a 2 sine theta by 2 cos theta by 2. Another way in which we can write 1 minus cos theta is a is as it is 2 sine square theta by. Now if you are very comfortable with trigonometric identities, then only you will be able to figure out this text. So now this is not y is equal to, this is dy by d theta. Okay, so now we want dy by dx. So dy by d theta divided by dx by d theta, which gives us dy by d theta is minus a 2 sine theta by 2 cos theta by 2 divided by a 2 sine square theta by 2. So one of them gets cancelled, a gets cancelled, 2 gets cancelled. So we are left with cos theta by 2 sine theta by 2, which is cot theta by. Now second derivative d square y by dx square. How do we do this? We can't just differentiate this. We will have to differentiate dy by dx with respect to theta, and then divide that by dx by d theta. So differentiate this with respect to theta and then divide dx by d theta. So let's do that. So minus cot theta by 2 is, if we differentiate it, we get cosec square theta by 2 times, and then theta by 2 has to be differentiated. So 1 by 2 divided by dx by d theta. Dx by d theta is here, the denominator part, or we can look here also. Dx by d theta is this. So 2a sine square theta by 2. Now this is just simplification. Now 1 by 2 will go down, so 1 by 4a times cosec square theta by 2 can be written as 1 by sine square, or sine square can be taken up. So 1 by sine square is cosec square. So cosec square theta by 2 times cosec square theta by 2, so which is equal to cosec 4, this is cosec cosec 4 theta by 2 divided by 4. So you have to be careful when it comes to differentiating parametric functions. Let's do another one. So let's say x is equal to 3 cos t minus 2 cos cube t, and y is equal to 3 sin t minus 2 sin cube t. So dx by dt equal to minus 3 sin t minus 2 times 3 minus sin square t. No, not minus. Cos square t and then minus sin t, which is equal to 3 sin t is common, minus 1, minus into minus plus cos square t. 2 is remaining here, so 2. Now this is equal to 3 sin t cos 2t. Now let's look at dy by dt. Now this will give us 3 cos t minus 2 times 3 sin square t, and sin t is cos t. So here 3 cos t is common. So 1 minus 2 sin square t, okay, minus 2 sin square t. Okay, and this is equal to what? Cos t, and this side is also equal to cos 2t. So now if you want dy by dx equal to dy by dt divided by dx by dt. So that we get, okay, so dy by dt is 3 cos t cos 2t divided by 3 sin t cos 2t. So cos 2t goes off, 3 go off, and we are left with cos t by sin t, that is cot t. To get the next derivative, second derivative, we need to derive. We have to find the derivative of dy by dx, no, dt, dy by dx with respect to t, and then divide this by dx by dt, so that this dt gets cancelled. Okay, so let's do the first one. This is cot t. Cot t is straightforward. This is straightforward, no complicated. This one. So this will be equal to minus cosec square t, and dx by dt we have already done. Dx by dt is 3 sin t cos 2t. Cos 2t. Let's take it 1 by 3 sin t times sin square t cos 2t, which is minus 1 by 3 sin cube t and cos 2t, or you can take sin t above. So just be careful about the second derivative onwards. Okay, so first derivative, remember to find dy by dx is equal to, if the parameter is t, then you have to find dy by dt divided by dx by dt. To find the second derivative, you have to find the derivative of dy by dx, first derivative, which is what normally we do. But here you have to divide it by, again, dx by dt. Okay, I think that's enough for today. Bye for now. Please go to the about page of my channel, and here you will find various links for each topic. These are Excel workbooks which I have been using in many of my videos. Download it and practice.